Greetings everybody. Welcome to a brief video presentation on the 4-stroke petrol engines. Let me introduce you to myself. I am Bharath M, belonging to second semester of Audi section, Sri Venkateswara College of Engineering, Bangalore. The subject I am going to present today is Introduction to Mechanical Engineering. The topic would be the 4-stroke petrol engines. As we speak about the 4-stroke petrol engines, let us first look at the person who invented this engine. This concept of four-stroke internal combustion engine was attributed to Nicholas Otto, who is a German inventor. The person by name Nicholas Otto invented the four-stroke engines. This design he patented in the year 1876. After he took the patents for this led to the foundation of modern internal combustion engines. There are a lot of advancements which came through after he patented his design. Now let us see what are the basic principles of the four-stroke petrol engines. A four-stroke petrol engine operates by completing four distinct strokes, that is intake, compression, power and exhaust stroke. The intake stroke draws a fuel-air mixture which is compressed during the compression stroke. The name compression stroke, it compresses. Ignition of compressed mixture occurs in the power stroke. When you ignite, there is power released, and this generates power, and the resulting exhaust gases are expelled during the exhaust stroke. Now, see, these are the four strokes. The intake stroke, air-fuel mixture is drawn in. The compression stroke, air-fuel mixture is compressed. The power stroke, explosion forces the piston down, and the exhaust stroke, the piston pushes out the burned gases. Now, all these four strokes, let us look one after the other. The first one is the intake or the suction stroke. Here what happens, the intake valve is open in the engine. This part is the intake valve. This is open during the suction stroke. The piston moves downward. The piston is basically first at the top dead corner in this place. This moves downwards towards the bottom dead corner. When this piston comes down, this creates a partial vacuum in the cylinder, and this vacuum draws in air-fuel mixture into the cylinder. Piston reaches the bottom of the cylinder and prepares for compression. This ends the intake stroke. Now, moving on to the second stroke, that is the compression stroke. Here what happens is the piston, which is at the bottom dead corner, moves towards the top dead corner. The intake valve, which was opened during the suction stroke, is closed during the compression stroke. When the piston moves up, there is already air and fuel mixture present inside the cylinder, and when the piston moves up, the air-fuel mixture inside the cylinder compresses. This increases mixture's pressure and temperature. When there is compression, pressure automatically increases, and where there is high pressure, there is high temperature, as both are proportional to each other. Here, the mixture becomes volatile and it gets ready for ignition and the subsequent stroke. The subsequent stroke here is the combustion stroke. The spark plug ignites the compressed air-fuel mixture. The spark plug, which is present above the cylinder, this ignites the compressed air-fuel mixture inside the cylinder. Here both valves are closed. This is to be noted. The ignition causes a rapid and controlled explosion in the cylinder. Energy is released in the form of expanding gases. When the petrol and the air mixture is burnt, energy is released in the form of expanding gases, and at this time, the piston moves down with a great force. This drives the engine's crankshaft, and this propels the vehicle. This is the last stroke or of the four-stroke petrol engine through a cycle. The four strokes this is the fourth stroke, known as the exhaust stroke. This occurs after the combustion of air-fuel mixture. Then here the piston moves upward. Piston is primarily at the bottom dead corner. This moves upwards towards the top dead corner. What we have to note here is the intake valve is closed and the exhaust valve is open. And what happens during this stroke is it pushes out the burnt gases and leftovers from combustion. After combustion, as we saw here, that it is explosion and controlled explosion and expanding gases. The gas which is present in the cylinder now will be pushed out during the exhaust stroke. These expelled gases travel through the exhaust system and is released out through the vehicle's tailpipe. See, hot gases in the cylinder escape through the open exhaust valve as the piston rises again for the exhaust stroke. Now, as we saw the opening and closing of valves, in the first stroke the intake valve is open and closes, and in the last stroke the exhaust valve opens and closes. Here in the valve timing and the operation of valve, intake valve opening, intake valve closing, then exhaust valve opens and closes. The proper timing of these valve events are crucial for engine's efficiency, performance and emission control. Usually they are controlled by the camshaft, which determines the duration and timing of valve openings based on engine's design and intended performance characteristics. See, this is the camshaft, the long rod-like structure present in the hands of the worker. This is the camshaft. This controls the valve timing and the operations of the valve. Now, let us look at a few advantages of the four-stroke petrol engine. They have a high revving capability, low weight and compact design. It's a very big advantage because they don't um, weigh more, and the design is also very compact, so it gives a better performance, better cold weather performance. As you have seen in the diesel engines, they don't have a better performance in cold weathers, but petrol engines have a decent advantage over the diesel engines in this matter. Lower initial cost for small engines. The petrol engines don't cost very high. Ease of maintenance. Petrol engine maintenance is very easy as compared to the other type of engines, and there is a smooth power delivery in the petrol engines. Let us look at some of the applications of the four-stroke petrol engines that are used for powering recreational vehicles. They are for small aircrafts. As you see this, smaller aircrafts, they run on petrol engines only. They are used in motorized bicycles. If we can see this image, this is a motorized bicycle. Now it is trending, the electric bicycles are trending, but motorized bicycles are also seen. Motorized garden equipment, they're used in trimming, shredding of the plants or the lawn. Then portable power generators, that is used during camping tours and off-road vehicles or any kind of vehicles. They all have petrol engines. But now let us go for another topic of the same subject. Four-stroke petrol engines. When we speak, why do we prefer a four-stroke petrol engine when we already have two-stroke petrol engines? Two-stroke engines were there from before. Four-stroke came into the market very recently. But why is four-stroke engine preferred over two-stroke engines? Let's look at some smaller points. Um, Four-stroke engines generate more torque. In general, four-stroke engines always make an extra torque than two-stroke engines at very low RPM. Although two-stroke ones gives higher torque at higher RPM, but it has a lot to do with the fuel efficiency. There's a more fuel efficiency in four-stroke petrol engines than two-stroke petrol engines because fuel is consumed once every four-stroke, whereas in two-stroke petrol engine, fuel is consumed once after every two-stroke. This logically reduces 50% of the fuel consumption. There's very less pollution because the exhaust gases are left out once after every four-stroke, whereas in two-stroke petrol engines, they are left out once after every two strokes. Here, the four-stroke petrol engines have a higher durability. Now, we all know that more the engine runs, quicker it wears out. Two-stroke engines are designed for high RPM. If an engine can go for 10,000 RPMs before it wears out, a four-stroke engine with 100 RPM will run for 100 minutes than the other two-stroke engine, which has a higher RPM of 500 and will run for only 20 minutes. The last point here is no extra addition of oil. Oil is to be added for the diesel engines, whereas for petrol engines, no need to add extra oil or lubricant to the fuel. Thank you very much.